we're going to be talking about we're going to be talking about speed and distance and velocity. So how fast things move, what direction they move in, traveling back and forth. So just kind of stuff like that. But we talk about that stuff all the time, right? If you're driving, you talk about how fast you're going, but we're going to talk about the technical terms for it. All right. So we're going to start here. All right. So the first blank, it says motion is, and I'm going to type right on top of it so you guys can see. Motion is relative. Okay, motion is relative. All right. And what that means is it really depends on kind of like your point of view. And I'm going to show you guys a video in just a second so you can understand what I mean. Okay. But the way we describe it is a change in position. Okay. Relative to a reference point. So I'll let you get that down and then I'll tell you what I mean by that. So basically, if something is moving, okay, for me to say that I dropped this spoon onto this plate, for me to know that this spoon is in motion, it's because the plate's not moving. And I'll show you a video of what I mean. I think this video is pretty cool, okay? So tell me, I think it's kind of trippy, but I like it. So let's look at this video. All right. You guys make sure you tell me if you can hear it. It's not going to be sound initially. Here it goes.
We're used to seeing things from a particular point of view. That is, from a particular frame of reference. And things look different to us under different circumstances. At the moment, things look You look peculiar. You're upside down. No, you're the one that's upside down. No, you're upside down. No, I'm not. He's the one that's upside down, isn't he? Well, let's toss for it. All right. Okay. You lose. He's the one that's really upside down. You better come into my frame of reference now. My frame of reference was inverted from what it usually is. That view of things would be normal for me if I normally walked on my hands. This represents a frame of reference. Just 3 rods stuck together so that each is at right angles to the other 2. Now I'm going to move in this direction. You see the frame at the same spot on your screen, but you know I'm moving this way because you see the wall moving this way behind me. But how do you know that I'm not standing still and the wall moving? It was the wall that was moving.
Makes you think.
Now the wall has disappeared and you have no way of telling whether I am moving or not. But now you know that I'm moving. The point of this is that all motion is relative. In both cases, I was moving relative to the wall, and the wall was moving relative to me. All motion is relative, but we tend to think of one thing as being fixed and the other thing as being moving. We usually think of the earth as fixed, and walls are usually fixed to the earth, so perhaps you were surprised the first time when it was the wall that was moving and not Dr. Hume. A frame of reference fixed to the earth
is the most common frame of reference in which to observe the motion of other things.
Kind of trippy, right? So I like that video because it talks exactly about like why when we say that we're moving, when we say we're not moving, it's really relative, right? So I don't know if anybody's ever done this, but I have been in a car before, and let's say I'm parked at the gas station, okay? But let's say that I kind of like, maybe I just woke up from a nap. I can see the car next to me moving, but I think that I'm moving. Like I'll be like, oh, did I take my foot off the brake? And I'm like, oh wait, I'm not moving, the other car is moving. So it's all very relative, okay? All right, so today what we're gonna focus on in terms of motion is distance and displacement. Oh, let me talk about this. All right, so this says if you are sitting in a desk right now, you are still moving quite fast. So most of us are sitting down or laying down or whatever, and you're like, I'm not moving unless like maybe my hand's moving, but I'm not really moving. But if you really think about it, you're not moving relative to whatever you're sitting on, but technically you are moving right? If the earth is moving and you're on the earth, you're probably moving, right? And the earth is moving two different ways, right? The earth is moving this way, right? So it's rotating on its axis. And then what's the other way it's moving? Anybody know? It's rotating around the sun, right? So like really the earth is doing this and going in a big circle as well, right? Which is, if you go way back, how we get our seasons and night and day and all that stuff too, okay? So motion is very relative, okay? I'm sitting here and right now I could either be moving left to right or I could be being still and moving my laptop, okay? All right, so let's get a couple more definitions and then we are going to start. Distance. Distance is the total length, L-E-N-G-T-H, length, okay? Covered during a trip, okay? Distance is the length covered during a trip, okay? Displacement, on the other hand, is, how far you are from a reference point, okay? How far you are from a reference point, okay? So let's talk a little bit about that. I think there's a video here, but I don't remember what it is, so we're not gonna look at it. Usually when we measure distance, so tell me one way we can measure distance, like a unit. How far?
In feet.
In feet? All right, so that's okay. What's another way? We got feet.
Meters.
Meters, very nice. Very nice. Okay.
Dang, y'all say something. I can't even say the answers.
I know, right? All right. Say again. What'd you say?
Yards.
Yards, yes. So yards, feet, meters, miles, kilometers, or some of us say kilometers, right? So the SI unit that we're gonna, most of the times in science, what we're gonna use is kilometers, and the shortcut for that is km, or meters. Okay, and the shortcut for that is M. You don't have to, you can just write M or KM if you want. I know your box is way smaller than that. So you can just put KM or M or meter. Okay, you can put whatever you want right there. Okay, so let me give you a visual of the difference between distance and displacement, and then we'll go into the worksheet. So before I do the visual, it says if you walk around a track, so remember a track is a big circle, right? Big circle, okay? And if you walk around it one time, It's a fourth of a mile or a quarter of a mile, okay? Or 400 meters, okay? So if you walk around a track, if you start here, you walk around a track, and you end back here, your distance was 400 meters or a quarter of a mile. Your displacement though, this is my reference point, this is where I started. My displacement when I started here and came back, and I came back right back to where I started, is 0, okay? Because I started and finished in the same place, okay? So if I get up and I walk, I don't have a meter stick, but if I walk to my wall over there, and I'm just gonna count my steps, that's what I'm gonna use for measuring. So 1, 2, 3, 4, 5, 6, okay? And I walk back 7, 8, 9, 10, 11, 12. I took 12 steps. That was my distance. But my displacement is 0. I'm right back where I started, okay? All right, so on this number 2, it just says, Sally walked 200 meters east, and you don't really have to know your east from west, right? But you can know their opposites. So if Sally walked 200 meters, let's say she started here, okay? So look at my finger. She walked 200 meters this way, okay? And then it says she walked 300 meters back the other way. So she walked past this point back to over here. So in total, she walked 500 meters. She walked 200 meters one way and 300 the other way. If we add those up, that's 500. But her displacement, she's only 100 meters from where she started. So her displacement is just 100. Does that kind of make sense? Anybody have questions thus far? You can unmute or raise your hand. That'll probably be easier than writing in the chat box. All right, so far so good. All right, so I want you to take a second and try and pull up that worksheet that we're going to work on, okay? It is, remember, it's in the, if you go to the 1D folder, so I'm going to start back from the beginning, okay? If you go to 1D, and then if you go to distance and displacement, this has today's date on it. And then if you click this. So remember when you click it, I'm trying to remember, I'm gonna have to record it one day, but you click this and then you click, at some point you click a blue edit button, okay? And that's what's gonna open yours up, okay? When you open it, it should look like this, okay? All right. I'm gonna give everyone just a second to open it. And then I'm gonna talk about it for a second, and then I'm gonna put us in the breakout rooms, and hopefully people will say, hey, did you get this for number 1? Yeah, I got that. Great, we're all smart, and we're all gonna finish this before the class ends today, okay? All right, so here's what we got. This is position, distance, and displacement. You should have, when you open it, 6 pages. I know it sounds long, but I promise you, I had people finish in like 15, 20 minutes, okay? All right, so if we look at this, the first part is just talking about how to read positions, okay? So they gave you like this little number line. And for instance, on this question, they said, what is the position, okay? What is the position of the lightning bolt, okay? So if I go find the lightning bolt, it's right here, okay? And it's at the 5, and then this whole line is meters. So this is 5 meters, okay? Smiley face is at 1 meter, that's what they put there. And then the sun is at -4 meters, so that's what they put there, okay? So now when we go to the first question, anytime you see these little pink boxes, that's what it means you can write in it. It says, what is the position of the heart? Kevin Nunes, could you tell me the position of the heart? What would you put in the first box?
4 meters.
4 meters. So right there, you guys are going to type 4 meters, okay? And then so on and so on. And this is just telling you where to put stuff. So see, look, we're already done with the first page. Second page, they're asking you some stuff. What's the initial position? It says initial, so you just write what that is. Let me skip down to the 4th page for a second. I just want to show you this one thing, and then we're going to go into the breakout rooms. All right. There is a part on the 4th page that says draw is coming. Sorry. Draw an arrow showing an object moving from -4 meters to the 5 meters. I just want to show you how to draw an arrow on here. If you go up to where it says insert, okay, and you click it, and then you come all the way down to where it says line. And once you just, if your mouse is just on there, there's this part that says arrow, okay? And the end of the arrow is the last thing that's going to be drawn. So I'm just going to draw an arrow. I'm not following directions, I'm just trying to draw an arrow. So as soon as I hold down my mouse and I drag it over, and when I let go, it's going to draw an arrow. Okay, so that's how you draw an arrow. All right, any questions so far? All right, we're going to do breakout rooms. If you got a question, remember you can raise your hand in the breakout room. Try to talk to each other so we can get this done, okay? Yes, Leo.
How do you do the arrow?
Okay, if you go to insert at the top, and then you come down to where it says line, and then you go over to where it says arrow, and you click that. And then all I'm gonna do right now, I just clicked my mouse, I didn't let go, and then I just moved it. So you could move it any way you want, right? I'm just holding on to my mouse button. So I'm gonna hold on, I'm just gonna drag it. And then as soon as I let go of my mouse button, there's an arrow there. So you just gotta know where to start and finish based off of what they asked you. Okay? All right, here come the breakout rooms. I'm just gonna pop in and see how you guys are doing. I'm gonna keep them fairly small so I can talk to everyone.